Let's learn about radicals or square roots and cube roots. You know, a lot of times in map testing and other scenarios, you've already seen these types of problems before, and they're just asking you a simple question of, hey, what's the answer of this? And you just don't know how to interpret what it's asking. But if you remember back to 7th grade math, maybe 6th grade math, depending first time that you saw it, sometimes you would see questions and they would just say, hey, how far from 0 is negative 16? And you knew the answer. Well, it was 16 spaces. And then in 7th grade, we taught you what the sign for absolute value was. We would put that number in between two vertical lines and say, hey, how far away from 0 is, and then whatever the number is inside of it. And the same thing's true down here. It saved a lot of time with this sign. And in the same respect, the square roots are just asking yourself a question here. What number times itself is 64? And we know that 8 is the answer because 8 times 8 is 64. But instead of writing out this whole question of what number times itself is 64, what we'll do is we'll make a check mark and then a straight line coming right off of it. This is called a radical sign. Let me spell that for you, R-A-D-I-C-A-L. That's the true name of that sign. However, a lot of times we'll call it a square root. And what we'll do is we'll put the number that we're curious about, that 64, underneath it. And so instead of writing out this whole question, we just put the radical sign right over 64, and we know that it's asking, hey, what number times itself is 64? Well, in this case, it's 8. Now, what number times itself is 16? Well, 4, because 4 times 4 is 16. But rather than writing out that whole question, isn't this so much better? What number times itself is 100? Well, how about we just do this? What's radical 100? 10. How many numbers can answer this question, though? How many numbers can we multiply by itself to equal 100? Keep in mind we can't add, we can't divide, we can't half it, can't do any of that. It's got to be a number times itself. Well, we've got 10 times 10 equals positive 100. We also have negative 10 times negative 10. And that equals positive 100. So sometimes you might see the answer is saying, hey, it could be positive 10 or it could be negative 10. But keep in mind it does not mean this. 10 times negative 10 would be negative 100. And so that's just wrong. It would be either positive times positive equals positive or negative times negative equals positive. Because we are not in the land of having to worry about, hey, what's the square root of negative 16? Because it's not 4 and it's not negative 4. But we don't have to worry about that in 8th grade math. What number times itself 3 times is 8? And if you stop and think about it, it would be 2. Because 2 times 2 times 2, let's do the math, 2 times 2 is 4, and 4 times 2 is 8. So what we do instead of asking this question, we'll put that radical sign there, but we'll put a little 3 right there in front of it. And we call this a cube root. Hey, what's the cube root of 8? 2. Or what number times itself 3 times is 8? 2. That's what it's asking when we see this type of sign. Now, the cool thing is that if you're dealing with cube roots, really, if you just stick with these right here, you'll be okay. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So if I said, hey, what's the cube root of 512? Don't panic. It's going to be one of these in 8th grade math, basically. And you'd see the answer would be 8. What would the cube root of, oh, let's do 729. Cube root of 729 would be 9. What I would recommend is if during a quiz or test you came into some cube roots that you didn't know, I would start at, whatever level you don't have memorized, maybe with the 4s. 4 times 4 is 16, 16 times 4 is 64, and just make this list off to the side, and it'll get you through the cube roots in no time.